everyone, this video is going to introduce covalent bonding. Just a reminder, we have two types of bonds. We have ionic bonds and covalent bonds. Ionic bonds are between metals and nonmetals, and covalent bonds are between nonmetals and result from the sharing of electrons between two atoms. So if you look at the example here, we have two hydrogen atoms. Okay, there's hydrogen's one valence electron, and when these orbitals get close enough, remember our electrons reside in orbitals, and when they get close enough to each other, their orbitals overlap. Okay, that's what a bond is actually, is orbital overlap, and where electrons can be shared between them. All right, and so we also represent this, and you'll see this often, with just a line between the two, and that is a covalent bond, and it represents two electrons in the bond. So there are two electrons in every bond. Okay. The term molecule is the means that we have a stable arrangement of atoms held together by a covalent bond. So when we say the term molecule, this is what we are referring to. Okay, if we have a covalent bond between hydrogen and now fluorine, okay, and so we show this, they're going to get close enough together. So we'll just put circles around here, but their orbitals get close enough in proximity where they make a covalent bond. Okay, so they share two electrons, and we also represent this by a line. So there's two electrons in the bond. Atoms are going to share electrons so that they can obtain a noble gas configuration. So we've been saying that sort of over and over, same thing with our ionic compounds. And so hydrogen is the one that only wants to have two electrons around it, because we know it's the first element and it just needs one electron to be like helium. Okay, however, if you look at fluorine, okay, it's in group 7 on the periodic table, and so it wants one more electron to have 8. So remember our octet rule here. So all other of our main group elements, which are going to be the only ones we're going to work with, they want to have 8 electrons. So if you look at our, this is actually a Lewis structure here, you see that hydrogen has 2 electrons next to it. So it is sharing those two, so that means it's happy. Okay, and then fluorine has 2, 4, 6, 8. Okay, and that means that it is also, happy, because it wants to have 8 around it. Okay, the electrons that are not in a bond, they're called lone pairs or non-bonded electrons. Okay, so this would be bonded, that's a bond, but these 2, 4, 6 electrons here that come in pairs, okay, those are our lone pairs. We're going to learn to draw Lewis structures, but first we just want to show you what they look like and what that means. So a Lewis structure is basically the bookkeeping of electrons in a molecule, and it's showing with lines the best way that we know how to show the structure and the arrangement of atoms in a molecule on paper. Okay, and so in reality, and we're going to talk about this later, okay, a lot of these molecules are not flat. So they're not flat on paper like we show here. So that's why there's some models beside these to kind of show you that they do, some of them have 3 dimensions. But what I want you to look at is, so here's methane. So if we look at the carbon, methane is CH4. Okay, it has 2, 4, 6, 8 electrons around it. And so we just go ahead and draw bonds for these. Okay, so each of those 2 electrons those are the same as drawing a bond. Okay, so carbon has 4 bonds around it. So if we count 2, 4, 6, 8, then carbon has a full octet. Okay, hydrogen is also happy because it just needs 2, and it is sharing 2. All right, the ammonia molecule is different from methane because if we draw its Lewis structure, and like I said, you'll learn how, okay, and you have just 3 hydrogens, so ammonia is NH3, so you have 3 bonds to hydrogen. Hydrogen is happy the way it is there, okay, but if you didn't have a lone pair, it would only have 6 electrons, and so nitrogen has a lone pair of electrons on the central atom, and this lone pair, okay, it significantly changes reactivity as well as the geometry of the molecule. Okay, and so we have a lone pair here, so 2, 4, 6, 8. Okay, water we know is H2O, so most of you think about drawing it, you might just draw it like this. Okay, if I was just starting chemistry, that's what I would think. Okay, but if we look at the oxygen, it doesn't have 8 electrons around it, so we know that it's not going to bond in a way that it's not stable. Okay, and so our hydrogens are fine. They always have this one bond. Okay, they never have lone pairs because they want that one bond, and that's all. Okay, but oxygen has 2 lone pairs around it because it needs 8 electrons to fill its octet. So 2, 4, 6, 8. Covalent bonds are formed mainly between nonmetals. It can be a metalloid and a nonmetal, but we want to think about how many covalent bonds will form for a particular atom. Okay, and so one way to do this is just a little formula, and you can even just look at your periodic table and tell, but if you take the number 8, because we know we have 8 is our octet, okay, then if atoms with 4 or more valence electrons, which our nonmetals have 4 or more, then you can take 8 minus the number of valence electrons for the element that you're looking at and you're trying to draw or look at its covalent bonding, okay, and you can subtract that. So let's pretend we have oxygen. Okay, oxygen is in group 6, so it has 6 valence electrons. Okay, and so we get 2 bonds. That's the predicted number of bonds that oxygen wants to form. Another thing that I'm not sure, I can't remember if I mentioned, but Lewis structures represent valence electrons. So that's what we're looking at and I'm going to be discussing further. All right, so oxygen, that was our example. Okay, hydrogen only forms 1 bond, so just need to remember that because it only has 1 valence electron, so we don't put it into our formula here. Okay, so if we do this for all of our groups, okay, we're using carbon, nitrogen, then oxygen, and then our halogens here. Okay, we can sort of see the bonding patterns and be able to predict the number of bonds that an atom's going to want to make when it reacts or it shares electrons with another atom. So if you look at hydrogen, it only makes 1 bond. So we've already established that. It has no lone pairs on it. So this never occurs. Okay. All right. And then if we go on over, so we're going to move to our nonmetals to carbon. Carbon is in group 4. So if we take our 8 valence electrons minus 4, carbon always makes 4 bonds, and when you start arranging these in Lewis structures, it also always wants to be in the middle. It likes to bond to things. It likes to be the central atom. So we have 4 bonds around. So if you count 2, 4, 6, 8 electrons, 2 electrons in each bond, then it has no lone pairs either. Nitrogen, as we saw in our example, of ammonia, it is in group 5. So it forms 3 bonds. Okay, so if it forms 3 bonds, that's 2, 4, 6 electrons, but that leaves a lone pair because it needs 8. So it has a non-bonded lone pair on it. So it has 1 non-bonded pair. Okay, and we saw in our example with water, okay, that 8 minus 6 equals 2. So oxygen's in group 6, so it wants to form 2 bonds. Okay, therefore, it has to have 2 lone pairs because it has to have an octet of 8. 2, 4, 6, and 8. Okay, for our halogens, they're in group 7. So they want to form 1 bond, just like hydrogen. However, they're going to have 3 lone pairs around them. 1, 2, 3. Okay, and therefore, if you add all those up, you get 8. We know that they bond in a way to have 8 electrons. The only exception is hydrogen, which wants to have 2. Okay, and just to focus on our human body, there are many covalent compounds related especially to the chemistry of the heart. And as you can see here, there's examples. Water, H2O, obviously is a huge component there. Nitroglycerin, glycine, O2 is also, so oxygen is a main component there as well. But this is just an introduction to covalent bonds, but very important because next we're going to look at being able to draw Lewis structures and covalent bonds. Thank you.